On now. So welcome everybody tonight to our first program of this new year, 2021. My name is Jamie Jackwood. I am the Assistant Director for Campus Sustainability at Umass Dartmouth. This is a program of a long time in the coming. We actually had planned this to happen last spring. We were gracious enough to have several people who had this idea that we realized there's lots of things going on in the wind energy space, and that we were wanting to keep the community sort of abreast of what's happening, both in terms of where alternative energy is going, what some of the possibilities are, but also some of the complexity that comes along with that. It's not just about putting up a wind turbine someplace or siting some solar panels. There's an effect on sort of the surroundings, and there's a lot of really, really smart people who have been working in this space for a long time. And so we wanted to pull together varying facets of this, from policy to the environmental impacts of that, along with industry partners who are building this new economy in the South Coast. And I think we've got a really great collection of people here. I do want to give a shout out to David Cole, who was one of the original organizers of this, who put a phone call into me and said that he'd like to be able to pull groups together to do this. And so I appreciate his initial sort of the sand that started the pearl inside of the oyster there. With that, just a couple of ground rules for everybody tonight. For those of you who have been watching sort of the internet and how Zoom meetings are taking place these days, there's been an increase in the amount of people sort of floating into other people's meetings and causing chaos and disturbance. We had another instance of that several weeks ago at the university with some of our students at an event. We had it happen last night at one of our faculty meetings. And so we've actually drawn in a couple of folks tonight who are going to be helping me to sort of manage who's in the meeting and if there's any kind of challenges or problems. So this does look a little bit different for some of us. We've got your microphones turned off. We've got your cameras turned off. There's no pictures from anybody else. But we do have the presenters who are on right now. And they'll be, I'll be sharing my screen to be able to sort of run the slides through of all of this. We are going to be taking questions at the end of this program, and so we encourage people to be able to add those. We'll be monitoring the chat session for those, and for those of you who are interested in actually asking a question in person, if you look down at the bottom of your screen, there's a little place called reactions. That's a place where you can put up a smiley face or a thumbs up if somebody makes a really great point. But when we get to that, there's a place for you to raise your hand. So if you do want to ask a question in person, if you raise your hand, we'll go ahead and recognize you and unmute your microphone for you at that time. If you're not comfortable asking a question, you feel free to put it into the chat session, and we'll try to sort of congregate those kinds of things together and come up with themes or specific questions that myself or one of the other moderators can sort of bring forward for us. So that's kind of the rules of what we're going to be doing tonight. And with that, I'm going to go ahead and start sharing my screen. And I'm going to hand this over to, actually, just to myself, I guess, as I sort of intro this. So we are there. And if we play this bad boy from the start, I'm hoping you can all see Harnessing Wind Power in our title screen. That looks familiar to the poster that you have seen coming into this. Here's a couple of partners that all came together in the sponsoring of this event. We are the Sustainability Initiative, but Mass Audubon was really there from the beginning with us. Serped is another organizer, and New England for Offshore Wind is another group that was helping to sort of pull this together and help to publicize and advertise this. So with that, Paul, why don't I hand it over to you and let you sort of drive things from here?
Thank you. And Jamie, one more technical point. Could you check on Heidi's status as a co-host rather than just as a participant? We're trying to get her video activated on our end.
Terrific.
So if you could just do that while we're starting up. Welcome to everyone. I'd also like to echo Jamie's recognition of Dave Cole for having a foresight to build awareness about offshore wind and its opportunity. Not a lot of people know about offshore wind and what it represents. which kind of explains why you need things like this. It's such an enormous opportunity, and so few people know about it. We're hoping that you'll help spread the word tonight. So congratulations to David for having the vision, and for Jamie Jackwood at the Sustainability Center, and Brian Sullivan and the IT folks at Umass for giving us the backup. I'm going to apologize in advance for the nature of Zoom. I don't own Zoom, but I notice anytime I use it, maybe you've all had this common experience that sometimes I'm in the middle of a sentence and my mouth just freezes, and that was the Panama, of course, but periodically the thing's going to freeze on you. So hopefully that will just work its way out in terms of internet connectivity on your part, my part, somebody's part. So with that, Jamie, if you could just move into the slides. And my purpose today is to set a context for the other discussants, the other participants. And we're really here to, I think, explore these offshore wind development opportunities for the South Coast communities. You know, in addition to the benefits of offshore wind as a sustainable and low-cost source of renewable electricity, the industry really represents a new base industry for the country. People can't appreciate sometimes the scope of the big deal that this really is. So we're creating a new base industry, a new way to generate electricity in the United States, and it has enormous economic potential and impacts. The American Wind Energy Association, for example, estimates that by 2030, so that's only 9 years from now, that there'll be 83,000 jobs that would have been created, and 25 billion with a B dollars in economic impact. Now, to put that 25 billion, I mean, sometimes you can't get your arms around billion, right? But a bank, a typical community bank, is probably capitalized with 3 or 4 billion, right? So you're talking about projects, individual projects that are equivalent to the whole capital value of a bank. So it's a big deal, and that's what we're going to try to convey tonight, because ports are the way you bring jobs ashore. You have offshore wind farms, you have these interconnection points, and you have supply chain and storage development that are emerging industries and existing manufacturing industries, all of which constitute onshore economic development. And as a context setter, again, I'll say that in Europe right now, offshore wind represents about 23% of Europe's entire energy load, 23%. They only started in 1999, right? So prior to the millennium, it was close to zero. So in 20 years, they've gone to 25%. And I think this is a generally accurate description of the wind resource off the East Coast, but it has sufficient energy to support 4 times the current total national demand, 4 times the total national demand. So as a job creator, these 83,000 jobs are not pipe dreams. A few years ago, we did a workforce assessment on the Clean Energy Center, for the Massachusetts Clean Energy Center. On their website is a link that you can find to this report, which I've pulled out a table. I know it's an eye chart, but this was the projected employment by years for the first 1,600 megawatts of electricity based on the 2016 bill that Representative Haddad was so instrumental. So just for the first 1,600 megawatts, if you look at the lower right-hand number, it's nearly 3,000 total job years. That means a job for a full year for a person. So 3,000 jobs for 1,600 megawatts. Next slide, and you'll see how far we've gone from 1,600 megawatts. Do your own math. How did we get to where we are, right? So over the last 10 years, technology enhancements have increased the size and decreased the cost of offshore wind by a factor of 3. So you're looking at sort of cartoons of in the low extreme left, the custom house building in Boston. So these are not little things you see in the field when you drive down the road, right? These are things that are equivalent to skyscrapers. So that little windmill on the left, I say little, it was the Siemens Tower that Cape Wind in 2014. The next one is the Block Island 6 megawatt machine. The next one is, I think, Nate, the one you guys are using, right? The 9.5, or that may be the older one. Did you go to the 12 already? How did you go to the 12 already?
We're doing better than that, but I'll save it for later in the thing.
There we go.
13
All right.
now.
There you go. So, and then the last bubble on the right is the tower that currently Mayflower Wind expects to use in their project off of Massachusetts. And I put that next to the John Hancock Tower because I want to just give you an idea of how big these things really are. So if you move to the next slide, over the past 5 years, you know, when we were looking at 1,600 megawatts in 2016, things have changed dramatically. Massachusetts then was the first mover. I think, Pat, this is accurate, that Massachusetts was one of the first states that had a commercial purchase power agreement in place with a company that required the utilities to buy offshore wind electricity. So that's the dog, right? The Rhode Island and Massachusetts wind energy area was formerly, if you can imagine, a giant rectangle that went off the right of the slide. And in 2009, Rhode Island and Mass both did a fairly good ocean planning exercise, and they engaged ocean stakeholders to take out of the potential wind zone areas that might be significant fisheries, which you'll hear Kevin describe, areas that were sensitive migratory areas for whales and turtles and bats and birds, shipping lanes, all these things. So you end up with this, instead of a giant rectangle that's 1,000 square miles, you get this configuration. But those different colors represent the 5 lease areas that are off Massachusetts and the one that's off of Rhode Island. So we were really a first mover. And these are the ports that were sort of teed up to do that work. And if Jamie goes to the next one, you know, the challenge is that in the bidding process for Massachusetts really focused almost exclusively on price. And Nate's crew made a lot of believers of offshore wind when they submitted their bid, and the bid price came in at something like 7 cents a kilowatt hour, right? People were expecting in the teens at best. So these Northeast ports were really well positioned to do stuff. And the challenge is, you saw how big those devices were in the cartoon. Think of the ports you have up here. Think of the port cities. We don't have these giant 3,000 acre port facilities that are ready to go to take these gigantic components, do the subassembly, and then move them offshore. So it would seem to make sense that these local ports, even though they're interstate in their geography, would collaborate so we could make these hubs of activity. Next, please. In the last, 4 years then, state offshore wind commitments have grown by what engineers would define as an order of magnitude growth, right? It's gone from slightly less than 2,000 megawatts to nearly 30,000 megawatts. That is substantial growth. So how do we capture these jobs? Next. Jamie, if you could advance the slide one more. Thank you. You know, since the bill in 2016, again, which Pat really championed through the legislature, other states have picked up the drift, and there have been substantial solicitations from New York and New Jersey and other states since then. But when I look at, so for example, New York, I think, has something like 4,000 or 5,000 megawatts that they're soliciting right now. But this is the map of where the power will come from for the New York solicitations and the Connecticut solicitations. So you can see the wind is in the Massachusetts and Rhode Island wind energy areas. There's some off, obviously, Empire and the site south of that will play a role eventually. But right now, for all of the electricity that's going to New York and Connecticut and Rhode Island, for that matter, it's coming from these areas, whether it's Sunrise Wind or South Fork or Beacon. Those are solicitations that New York put out that the offshore wind companies bid against. But remember, we're in federal waters, so they're going to create electrons out there, and they're going to sell them to whoever buys them on the shore, and they're going to connect into the grid at some point. And that's about, I mean, that's sort of a simplification of what's a big deal. But I point this out because I want to keep going on this idea. How do you attract the jobs? Look in the upper left-hand corner of this slide. Port of Albany is going to be a place that's manufacturing steel components for the offshore wind blades. Now, normally in Europe, they take these things out vertically, right? So you need a place that has no bridges and it's kind of right on the ocean edge. These are pipes that are going to go down the entire Hudson and then go all the way through either the Long Island Sound or the Atlantic to get out to New England. That's stuff that could be happening here. And the reason why it's happening in New York, I would maintain, and not happening here was because of the focus Massachusetts placed on price rather than local content. Next. Jamie, if you can move me one. Oh, there you go. I see you going. And again, this just illustrates kind of where that wind's coming from. The different colored graphs will point out the source of the wind energy and then the source of the consumption of that energy. Next. So I think this is where I end, and I want to say our challenge is how can this South Coast region position itself better to capture the offshore wind jobs and economic development. And the next few speakers are going to describe more about their areas of expertise, but in the background, I want you to think about how do we create jobs here rather than downstream? Because if you go back to the eye chart, you'll see that a lot of the jobs that are in that chart are in either the construction phase or the operation and maintenance phase. So the construction jobs last several years until the fields are built, but then the maintenance jobs last for 25 years. And how can Massachusetts get a better share of the economic development from the supply chain as well as from the operation and maintenance long stream? So as a context for tonight's discussion, I want to introduce a person who, in my opinion, is literally responsible for the creation of an offshore wind industry in Massachusetts. I've known Pat for a long time. You may know her as Speaker Pro Tem or as the representative of the 5th Bristol District in Massachusetts. But I can think of no other initial advocate for offshore wind, more enthusiastic, more supportive, and who exercised more leadership than Pat. We teased her for a while. She had a couple of nicknames that friends could call her. She was the Queen of Wind for a while until she started putting a foot down and saying, no, you gotta do this stuff. At which point she became the Witch of Wind, the affectionate wish of wind. But I truly believe we wouldn't have an offshore wind industry but for the passage of the 2016 amendments to the clean energy legislation. And Pat is the person who, in my view, did more than anybody in the legislature. So, Mademoiselle Speaker Pro Tem, welcome. Thank you for all you've done so far, and thank you for your continued leadership in this area. You made it happen. And I think we're going to Pat.
Yes, I just forgot to unmute myself. So thank you, Paul. And I don't have any slides. I'm just going to pretty much do stream of consciousness with you. I think it's, Paul has said it very clearly. The problem with what's happening in Massachusetts is that the attitude of the administration is that the price is more important than the big picture. I very often tell people that I go back to that that day in, I can't even remember when it was, in 2016, when I stood at the podium, and after, months of going out and, just pounding into people the importance of what I thought offshore wind was going to be to Massachusetts. Massachusetts leading up to this had done a lot of really important things, from the Green Communities Act. We were every year or every 2 years in every session, I think we did something important for the environment. But when we were in the actual 2014 or 2015 session, when there was so much talk about Cape Wind, but there was so much distress over where it was going to be built and what it was going to cost, that that the bill, we just, as a legislature, we could not in good conscience let something go through that was really going to be, ended up being costly, instead of balancing and getting us to a place where our energy sources were getting greener and our prices were lower. When we were going into all of this, it was every year when you looked at energy consumption and costs, we were always in the top 3, with New York, California, and imagine New York, California, and Massachusetts being in the top 3 for energy costs for business. So as Paul said, we really put a lot of effort into what a lot of people, using the information that a lot of people very graciously gave to me. We were invited to go to a lot of different places in the world to see what was already being done. Many of the developers spent a lot of time with me, and I had at one point, I could tell you anything about a coal-fired power plant, but we knew that that was not to be, and that we had to go on to a new generation and clean energy. So then it became my job to learn about clean energy and wind. So that brought us, as Paul said, to the very first utility scale procurement of wind in the country. And at that very same procurement, Rhode Island and Connecticut also jumped on board to get some of the megawatts as well. And that began what I'm very proud to say today is an amazing blossoming on the East Coast of great projects. I think New York might be up to 9 megawatts. So as we've continued, it has, and I will have to say that it has been challenging, because it's still, my colleagues, you can tell them about 83,000 jobs and you can tell them about $23 billion in income, but we're all 160 little individual people who have our little own business, which is what we do for our constituents. And you have to ask, what is it going to do for my world? So I'll just tell you that if you ever have the opportunity to speak with the people down at the Oceanographic Institute in Woods Hole, they will show you a map that shows you that jobs in the blue economy and green economy are all over the state of Massachusetts. And that is, I think most prevalent in the fact that the person who actually wrote the book on offshore wind is from the University of Mass in Amherst. So the jobs are everywhere, the thought process is everywhere, and we in Massachusetts continue. So that we put out first for 1,600 megawatts, another 1,600 megawatts is on the books. And this year in our bill that we called an act creating a new generation roadmap for Massachusetts climate policy, there are additional megawatts of wind. Again, there's some disappointment, because in this bill that, I could list all of the wonderful things we've done, from environmental justice to making sure that municipal lighting plants understand that they too have to participate and get us towards our 2050 goals. So we have 24 more megawatts of offshore wind. However, in the governor's veto letter, he informed us that he does not want to use that 24 megawatts only for offshore wind. He wants to use them for green energy. And okay, I'm very, good with that we all need to go further with clean energy. But selfishly, I think of those megawatts because I fought for them as my megawatts, and I want them to go to offshore wind. So we're going to have a battle over that. I want to tell you, because I've spoken with Speaker Mariano, and he wants to stand firm that not only are these offshore wind megawatts, but they are also, we also have to look not just to the price, but to what the economic development can bring. And the economic development, when I first brought this forward that night that we first debated this, I started not with about the energy. So I apologize to all you environmentalists that are on the webinar, but I talked about jobs. And the building of a new industry and the importance of actually having a new industry and the opportunity that it produced for the South Coast. And, being very parochial, the South Coast of Massachusetts was still experiencing the recession, that everybody else was kind of climbing out of it. And we were much more slowly climbing out of it. And I just happened to have in my backyard in Somerset, a switch yard that held, coincidentally, 1,600 megawatts that was not being used anymore for coal-fired power. And it just made sense that the they could plug in there and refill that part of the grid. Well, it started out pretty good, and I think that there has been some good investment in New Bedford, but it was always the hope of everyone, from the chambers to the university. There was just such a large consortium of us businessmen, business people included, that we saw the opportunities for the ancillary businesses, the supply chain, the local groups who made widgets to become part of this process. And to that end, we've had groups like this get together. And I think we've shown over and over again that we're ready. Bristol Community College is ready to do all of our training. And, there are still tracts of land. I keep telling people I'm standing on the shore of the Taunton River, waving madly, saying, there are 300 acres here. There are 300 acres here. And I'm going to lay it directly at the feet of the governor. He does not see I shouldn't. So let me not assign to him. Let me say that it would appear from the way things have gone that the governor's only interest is in the bottom line price that we would be, the big we of the people of Massachusetts will be paying for our electricity. And I'll just say that the businesses that I have spoken to are very willing not only to be part of this process where the price of power comes down because we're stabilizing it with big wind, but they're also willing to have more business come to the state of Massachusetts. So they're not so concerned, or the business people that I've talked to are more concerned with stability, to being able to project into the future what their power costs are going to be. And they are interested in bringing more businesses to Massachusetts. So it has become a bigger challenge. And so I would say to people on this call, as we go forward with our roadmap bill, we need people to contact the governor and talk about what it means, not only to go green, because green is so much of the economy now, but green that welcomes business, green that encourages business, and green that will interact with existing businesses. I'll just jump back to what Paul said in the very beginning about how the space in the water started out as a rectangle. And with the input of so many people, because we do not want in any way, shape, or form to encroach on the fishing industry. We don't want there to be any issues with existing business or the opportunities that are already part of the blue economy in the water. But we do want there to be a new and very vibrant industry in the state of Massachusetts. So I could go on and on, but I'm hoping that there'll be questions at the end. But I just want to tell you that as much as I'm complaining, I'm very proud of what the state of Massachusetts has done in energy efficiency, in having a plan and forcing there to be a plan going forward, and all we've done, to be helpful to bring a cleaner environment and cleaner economy to Massachusetts. So thank you for having me this evening.
Thank you, Pat, and thank you again for what you've done. For those of you who want to kind of drill down deeper about how these regional areas that aren't obvious places or places you might even have heard of become vibrant, revitalized offshore wind hubs, I would suggest you Google either the Greenport Hull, green as in Green Port, P-O-R-T, Greenport Hull, or the Humber Offshore Wind, H-U-M-B-E-R. And the Humber estuary was the second most bombed place in World War II after London, because it's kind of right up there in the North Sea, only 80 miles from Germany. And Pat's been there, and several of us have been there. And when you research Hull and Grimsby, it's like reading the history of New Bedford and Fall River in the UK, right? It's the place people move away from. Why would you go there? And the answer now is you would go there because it's the closest industrial ports to this giant wind resource that is able to adapt and take advantage of its natural resources, its maritime economy, and integrate ocean stakeholders. And with that, I want to segue to Ed Washburn, who I think now in his new title is Director of Business Development for Crowley Marine. And if you're not familiar, if the Crowley Marine isn't a household term to you yet, it will be, because when you're in the offshore wind industry, as well as just the sort of maritime and energy industries in general, Crowley is a big player. They've been a big player on the West Coast and throughout the world in its evolution as a family-owned business. And congratulations to Ed. Before that, you all know Ed as the director of the Massachusetts Port Authority, and he was really instrumental in positioning New Bedford as the epicenter. We would be at national conferences and people would know 4 places in the United States, right? New York, Washington, DC, New Bedford, right? You didn't think it was going to be in that queue, but it's because of some of the work that Ed and others have done to position New Bedford as not only the #1 commercial fishing port in the United States for 10 years running, and for which, by the way, Kevin Stokesbury has some responsibility. We'll get to that later. But that Ed understood that the ocean's a big place and can sustain on an economic basis multiple stakeholder groups and multiple user groups. So maybe perhaps in coordination with Kevin, Ed was one of the strongest advocates for the fisheries industry in the whole permitting process for offshore wind. He was also instrumental, and I think, a founding member of the Ocean Wind Cluster, which connects sort of the Internet of Things people with the maritime and ocean industry users in a really international network. So he had worked tirelessly to move the port forward, both as a fisheries resource, but as a blended model of coexistence in the ocean. And I just want to introduce Ed and ask him to take us through his work.
Thank you, Paul. I appreciate it. It's great to be here. It's great to see all of my old friends. I'm only 2 weeks into the into the new job, so it's almost like I went on vacation and I came back and I get to see all my favorite people again. Yeah, as Paul said, New Bedford is the #1 fishing port. We actually, I don't think we have the 2019 numbers, Kevin, but this would have been the 20th year in a row, and I think it likely will be
20th. Wow.
And a big part of that, just to make sure I am noting my esteemed panelists, a big part of that is Kevin's work and the science that he and Umass Dartmouth through SMAS have done. That is the reason why New Bedford is the #1 fishing port. It's the pragmatism, it's the openness to data, to science, and it's people like Kevin that have really led the way in that. And it's the fishing industry, the scallop industry in particular, that have led the way in that. And I think that is going to be that pragmatism that comes out of the Port of New Bedford is going to be really critical moving forward as we identify new opportunities with offshore wind. I'm going to go into a little bit of my new job today, but one of the key competitive advantages, and I know Kevin and everybody else in the region appreciate this. One of the key competitive advantages that our region has is the fishing industry, the know-how that exists in the Port of New Bedford of these areas, of all areas, the know-how of the ability to understand the impact, to the ability to go and work on vessels in any kind of weather conditions. All of that exists. The shipyards that we have that right now are tailored toward the ferry and the commercial fishing industry. All of that knowledge is what makes New Bedford and the South Coast and southeastern Massachusetts so competitive, and it really is exciting, getting into my new job as I start to look at key strategic partnerships. Southern New England and southeastern Massachusetts are going to be really critical going forward because of the scope of this, as Paul alluded to. It's massive. So as Paul said, I was the port director in New Bedford, and this is now my second week with Crowley. So Crowley is, as you can see, it's 129 years old now. It's had 3 CEOs. So the guy on the right is my boss, Tom Crowley. They're headquartered in Jacksonville, Florida, and they have $2 billion in revenue, 6,000 employees worldwide. And most importantly, as it relates to offshore wind, they own and operate 200 vessels. And there's something in the US called the Jones Act, which was passed in 1920, which says basically, if you're moving something from one US port to another US port, which any area within the exclusive economic zone of the US counts as a port, you have to move it on US built, owned, flagged, and crewed vessels. So the fact that Crowley is focused on offshore wind in such a big way indicates to me two really big things. One, that there's an ability for Crowley to really shape the offshore wind industry in the U.S. I think in a really positive way because of their interactions and their connections with the maritime academies, their connections with the U.S. workforce, their connections with the SIU and the unions. They're because of the infrastructure that they already have in the maritime space. Crowley has the ability to really make offshore wind industry a uniquely American industry. That's what I'm really excited about by joining them. So having the vessels and using the connections that they already have, Crowley, I think, is positioned, as I said, to really be able to solve the problems, solve the issues that are going to come up as we embark upon this massive undertaking. 30,000 megawatts, or no, 30 gigawatts of power, 30,000 megawatts of power. That's something like 2,000 turbines, 2,000 of those skyscrapers that Paul, put in his slides. That is such a massive undertaking in a country that doesn't have the infrastructure, doesn't have the workforce, doesn't have the manufacturing. It's going to take everybody. It's going to take a lot of companies, up and down the East Coast to really, and the Gulf of Mexico and the West Coast and other countries to make sure that we do this thing right. So as we look at what Crowley does, so I'm in the shipping division, the shipping business unit. So Crowley, their bread and butter is actually, a lot of it lies in the oil and gas space. So they ship oil from the U.S. to the Caribbean, oil from the U.S. to Alaska in the domestic trades. They also do LNG services. They've been really at the cutting edge of using LNG as a bunker fuel. So fueling vessels with LNG, which greatly reduces the greenhouse gas emissions and other emissions when they switch to LNG. Ship management, ship assist, and tug escort. That's mostly on the West Coast. Tugs coming in, bringing ships in. Uniquely, Crowley has a naval architecture, marine, and offshore engineering firm. So they can do in-house the design of vessels. They can do the project management and vessel construction management when those vessels are built. And to this date, they've been really active in the oil and gas space in the Gulf of Mexico, bringing large offshore vessel, structures out to deep water in the Gulf of Mexico for oil and gas. And they're looking at offshore wind and the competencies they have in oil and gas. They're looking at offshore wind as a big opportunity for their own businesses, but also to partner. They understand that they're going to need connections in these local ports. They're going to need local workforce. They're going to need local know-how in order to take advantage of this opportunity writ large. And that's where Crowley sits. There's three other business units. So solutions focus on ship management and supply chain solutions. Logistics is all sorts of third-party logistics providing, customs compliance, freight forwarding and warehousing, that kind of thing. And it has an entire fuels division with fuel infrastructure and supply and energy solutions that's mostly focused in Alaska. So they actually deliver that last mile fuel in a lot of remote communities in Alaska as well. You can go to the next slide, Jamie. So Crowley really sees, they really see offshore wind as something that they can really provide a turnkey solution throughout all the different aspects of offshore wind. So the tugs and barges that we currently have are all Jones Act. So feedering is actually bringing the components from the ports to the installation sites. Usually it's an installation vessel that's a foreign flag vessel. So that between as the offshore wind industry starts in the U.S., they're going to have to no vessels exist to be able to build these things out at sea. So you're going to need barges and tugs to bring the actual components out to the installation site. Modifying the assets in-house with dynamic positioning capability and using their articulated barge fleet to be able to do a feeder solution that works in terms of what is needed as the developers are trying to put these installations up. Accommodation and support barges, logistics and customs clearances, engineering services, and marine project management. These are all things that Crowley has done in the oil and gas space. And one of the things that was announced today, we're partnering with a company called Watco, another U.S. company that is one of the leaders in onshore wind turbine installation. So as we look at terminaling and installation and commissioning, we're going to be partnering with Watco to be able to provide those services to all of the developers and the turbine manufacturers. And then once we get through the commissioning stage, operations and maintenance, as Paul said, is a big part of the project. So designing, building, and operating the crew transfer vessels and the service offshore vessels are a big part of the plans ahead. And then the logistics and the warehousing for that operations and maintenance. These are all things that Crowley can provide and can do it while engaging with the local communities, identifying who the right partners are. And if those partners don't have the necessary skills or experience, being able to provide those to local industries because they have the workforce is a big part of kind of the value that Crowley can bring. Go to the next slide. So I apologize. It looks like some of the slides didn't come out completely. But in terms of the feedering, so monopiles, that's the foundation. Using the barges to go out there, again, that's a Jones Act move. And it's something that we can provide with existing, vessels and barges. We're obviously talking to all of the developers, including Vineyard Wind. Sorry, Nate. I need to update the slide. And then increasing the Crowley's footprint in the Northeast. And as I said, a lot of that is going to revolve around partnerships and engaging with the local ports, engaging with local shipyards, local tug operators, and doing it in a way that's comprehensive, that can provide solutions to both the service providers on the ground and the developers that are in a really extreme time crunch to get these projects moving. You can go to the next slide. As it relates to the actual turbine generators, this is the articulated tug barge concept that we're working on. And basically, these would ferry the components out to the offshore installation vessel from, for example, the New Bedford Marine Commerce Terminal. And this is something, again, that, the feeder concepts that we're developing and we're doing the models now would have the ability to quickly and efficiently get the materials out to the site and using existing U.S. resources and crews and local content. So it really is a big opportunity as the offshore wind industry starts in the U.S. and as Dominion and a few others are looking at building actual installation vessels. We think this could be a key way to do it sooner as the offshore wind industry develops in the U.S. You can go to the next slide. There's the Marine Commerce Terminal. And this is just the terminal management and marshaling services. Again, our partnership with Watco to be able to manage with the GEs and the Vestas, with the original equipment manufacturers, helping them with labor, with the stevedoring companies, the terminal management, all of those different local service providers, plugging them into the local ports so that we can get as much, if we have a big part of what we're doing with the New Bedford Ocean Cluster is if there's a hydraulics manufacturer or an electronics manufacturer that exists within the Port of New Bedford, there's no reason why you need to go, if you're an offshore wind vessel that's coming from another country, there's no reason why you need to go to your local Danish electronics supplier when we have the same thing right here in the Port of New Bedford. So making sure that we are plugging into the local port communities that already exist and that already do really, really strong and good things is going to be really important for the offshore wind industry to take off and show the jobs opportunities that we've all been talking about for years. And making sure that you have the sort of the boots on the ground to be able to make those promises and deliver on them is a big part of what we're focused on. You can go on to the next slide. And then again, on the operations and maintenance phase, crew transfer vessels, service offshore vessels, it looks like a lot of the offshore installations are moving toward the SOV model. So those are larger vessels. Obviously, a bigger capital outlay would be required, but making sure those vessels are serviced and maintained, the crews are serviced and maintained, and then coordinating the vessel management, coordinating the operations and maintenance management with the OEMs and the developers, and really being able to design vessels that can do this is something that Crowley can do in-house for the most part, and providing the developers with with really a turnkey solution in all of those avenues. You can go to the next slide. So these are the nice pictures, and this kind of gives you an idea of how a project would load out. So there's self-propelled motor transports. Those are moving the foundation pieces onto barges. You can see the wind turbine generators are behind it, and that would be a feeder solution again. And then the cassettes of the wind blades. So and coordinating all of that landside opportunity and the workforce is a really key thing, along with Watco. And then you go to the next slide. Offshore, looking at new build opportunities within Crowley's fleet for installation vessels, for articulated tug barges, and crew transfer vessels and the service offshore vessels. All of the different aspects. Many of these don't exist yet because the industry in the U.S. don't exist yet. But these are all the opportunities for U.S. shipyards, for U.S. naval architects, for U.S. mariners offshore that can really transform local ports here in Massachusetts and throughout the Northeast. And Crowley is ready, willing, and able to help this industry and help the local ports that will host this industry really take advantage of the opportunity. So I think that's all I have. I appreciate the opportunity to speak with such an esteemed panel, and happy to take questions when we're done.
Great, thanks, Ed. That was fabulous. And I want to build on something you said and described in your presentation. This notion of the Jones Act, the implications of the Jones Act on installation and the logistics involved with putting up a skyscraper in the sea. And when you overlay on top of that the thought that the European developers, they're accustomed to federal procurements largely from countries that are democratic monarchies, right? England, Denmark. So they don't understand this American. American concept of state rights, right? That Rhode Island and Massachusetts and Connecticut and New York would compete against each other to get the business, right? And Ed and I have talked about this quite a bit. This notion of, and your presentation illustrates the point I've been trying to make for a while, that it's going to be a slightly different industry here in the United States because we don't have these giant footprint port sites that are next to the wind areas. So it's going to require, and with the Jones Act, it's going to require the interstate collaboration among ports and port service operators like Crowley to do that. So, an idea that's kicked around is how can you induce better behavior between the states? The tendency naturally is to compete. And, one idea of a solution is to create a federal incentive structure that induces states to collaborate. So whether that's, accelerated permitting or access to federal infrastructure funds whenever they come out, or investment tax credits, production tax credits, landside tax credits, this notion of creating these offshore wind hubs that are kind of anchored in things that already exist. So opportunity zones already exist across the country through tax legislation. So your presentation was so dead on, and it just reinforced the thought several people have had about how do you build hubs of ports so that you get the geographic massing you need to make it convenient and efficient to move very large pieces. Let me segue now to Heidi Ricci, whose slide's already up on the board. Heidi's Director of Policy at Audubon, which you probably know was created in 1896, with the vision of trying to make nature a valued, essential component to our quality of life as humans, right? This notion that we as humans need to respect a complex ecosphere, and we see the consequences of our climate denial and inactivity in that area. So offshore wind produces an interesting opportunity, right, for environmental advocacy, because even though it's industrial development, the net impact is to create an alternative to a carbon-based economy. And one of the challenges we have that's been mentioned several times throughout the webinar is how do you balance the environmental interests and the other stakeholder interests with this opportunity to create a new energy industry. So Heidi, take us through your thoughts and how you feel about harnessing wind power.
Great. Thank you so much for that introduction as we shift gears a little bit here and look at some different aspects of this whole topic. And I want to thank Umass Dartmouth and David Cole and everyone involved in organizing this program, Rep Haddad for her support of offshore wind, and all of the speakers and everyone who's here tonight taking the time to participate. I really appreciate this opportunity. And so, as I said, I'm going to shift gears a little bit and provide some perspectives on both the effects of climate change and on offshore wind on people and wildlife. We're thinking forward to the future here. And unfortunately, this slide isn't displaying the way it's supposed to, but that's okay. Where are we headed? So Mass Audubon has been around for 125 years. This is our 125th anniversary this year. Our mission is to protect the nature of Massachusetts for people and wildlife. And I'm often asked why Mass Audubon and other conservation organizations would support the industrialization of the offshore environment. And the answer is very straightforward. We know that climate change is real, it's caused by human activity, and that we need to develop clean, renewable energy resources to make this transition to decarbonization by 2050 in order to avoid the very worst impacts. Abundant wind resources off the East Coast offer tremendous potential for clean energy production close to major population centers and energy demand loads. And then we also know that all forms of energy production have environmental impacts. So we support the rapid, responsible development of this industry. And that's, next slide. I'm sure that many of you are familiar with this information. Everybody that's here tonight knows something about climate change, but I think it's important, just as we're talking about the tremendous energy and business opportunities here, that we put it in this context of what we're seeking to avoid. Or at least minimize impacts. So the impacts are not just on temperature and changes in precipitation patterns, but we know that sea level rise is accelerating and that storms are getting more intense. And we saw that just last week with the big coastal storm and all the damage all the way up and down from the new inlet in Chatham to the houses that fell onto the beach in Sandwich, and damage up in the North Shore, Plum Island area, etc. And this is only going to continue and accelerate. Next slide. So, there's a lot of visualizations available. This is the Noaa sea level rise viewer, the mouth of the Merrimack River, Plum Island, the Great Marsh. And if we go to the next slide, we look at what we might be looking at in the future by the end of the century.
Wow.
Tremendous loss of the natural resources, the barrier beaches, the salt marshes that have such great ecological significance, as well as nurseries for fisheries, but also the damage to the built environment and the loss of those buffering capacities of the coastal resources, so that the next storm that comes along, when those barrier beaches and salt marshes are gone, the built environment in the upland is going to be all that much more vulnerable. Next slide. And then there's other impacts as well. Ocean acidity. The ocean has been, a great sink for tremendous quantities of CO2, but as that's happening, it's acidifying the ocean, and this is having tremendous impacts on marine ecosystems, all the way from the bottom trophic layers of the plankton, shellfish, fish, and all the way up the food chain. There was an article just in the Globe today about a new study that estimates that the US shellfish industry alone may suffer $400 million in annual losses by the end of the century due to acidification. Next slide. So, I am Mass Audubon, so I'm going to talk a little bit about birds, but really just as a, they're an indicator for so many other aspects of our natural environment and how it's doing. And when our birds are in trouble, we know that other species are in trouble, and in fact, people are in trouble and at risk as well. So climate is affecting birds and other wildlife in many different ways. Again, precipitation and temperature, but also throwing off the timing of different events, availability of food, like when invertebrates really have their maximum availability in comparison to when birds are breeding, for example. Sea level rise affecting coastal breeding birds, and just tremendous shifts in habitats and food webs. Next slide. Oh, I don't know what happened to this slide either. Must be a different version of PowerPoint, as I guess the last speaker had some issues as well. So this is Mass Audubon's State of the Bird report in 2017. We took a look at all 143 breeding bird species in Massachusetts through the lens of climate change. And we evaluated them based on 19 different variables and projected future trends and habitat ranges based on that. And the report is on our website if you want to delve more into what that methodology was. And there's also bird by bird profiles that you can read and maps that you can look at. But what we found was that about, well, a little more than 40% of the species are highly vulnerable to climate change, and another 15% likely vulnerable. And that's in the context of birds already being in significant peril. We know that of the Massachusetts species, 30% are already declining and in need of conservation action. And across North America, since 1970, there's been a net loss of 3 billion birds in the overall populations of birds. That's about 30% of all the birds that used to exist in 1970. So obviously it varies from species to species, but I mean, this is really serious because birds are not just beautiful and we appreciate them, but they provide many important functions for people. Some of them are pollinators. They consume tremendous amounts of insects that otherwise would be pests to people and agriculture. And they provide a host of other important ecosystem services functions. The birds' vulnerabilities are across all habitats, and I'll talk about that a little bit more, some more so than others. Next slide. And as you might not be surprised to find that the urgency is the greatest on the coast because of what I showed earlier, what's happening with sea level rise and increasing storm intensities. Some of our coastal birds that are already on the state and or federal endangered species list, like the roseate tern, where there's only about 4,000 breeding pairs left or less, and half of those are breed here in Massachusetts. The least tern is also state listed. Piping plover, everybody is familiar with, beach breeding bird. Next slide. And one of the very most imperiled is the salt marsh sparrow. When you consider what you saw on that map, and we know that salt marshes are at great risk with sea level rise. The salt marsh sparrow lives really on a very thin edge. In order to breed, they have to build their nests, lay their eggs, hatch the chicks, and fledge them all within a single lunar cycle before that high tide of the month hits. And with the sea level rise, that's becoming increasingly impossible for them. So the data is very sobering, and we really need to address this for this species and for others. Slide. So, but it's not only the endangered species that are going to be impacted by climate change. So our own state bird, the black-capped chickadee, which is ubiquitous and common all across the state, its range is going to be shifting, and it's likely that by 2050 it will not be present in large sections of the state. So that will be a loss for us here in Massachusetts. Next slide. And then there's impacts beyond birds. This depicts the landings of lobsters over time, and you can see how they're shifting dramatically to the north. And the lobster fishery south of the Cape is really just collapsing at this point. Next slide. Again, the title of the slide isn't showing, but the point here is that this is imposing new pressures on already imperiled species. So on the left, we have the North Atlantic right whale. There's fewer than 400 individuals left in that population. They're already under tremendous pressures and really at risk of extinction. And with the shifts in the warming currents and the shifts in marine food, plankton that they feed on, they're moving to different locations in search of that food. It's not clear whether they're going to be able to find enough, but just the fact that they're moving to different areas at different seasons than they used to is bringing them into greater conflict with things like lobster fisheries and entanglement hazards and the shipping lanes and collision hazards. So another example of already endangered species that are increased risk because of the warming seas are the sea turtles. We're seeing turtles like the Kemp's Ridley turtle stranding, with greater and greater numbers in the late fall on the Cape in recent years. And it's thought that this may be because the water is warming so much more up into the Gulf of Maine, drawing the turtles up further during the summer. And then when the fall hits and the water cools very rapidly, the turtles, many of them are not able to successfully make the migration back down south, become trapped on the Cape. And this could be, a real setback. There's been some successes in trying to revive this species by work on its breeding ground. But then if the juvenile animals are suffering, large numbers of strandings, what's that going to mean for the species? So, there's a lot of gloom and doom, but there is hope. And next slide. We got ourselves into this mess. We can get ourselves out of it. There are solutions. And clearly offshore wind is a big part of that solution. The middle graph here, there are different scenarios of when we're going to begin reducing our carbon emissions and getting to the point where we're reducing the impacts of climate change. And, the best time to do that would have been yesterday. The next best time is today. So we need to move forward quickly and get those emissions down as quickly as we possibly can, while, still being responsible and thoughtful in how we proceed with this development. Next slide. As other speakers have said, this is a proven technology. We have ample resources here. It's economically viable. There's lots of people working on developing all of the technology and engineering and equipment that's going to be needed, a lot of potential for workforce development, etc. Next slide. So what do we mean when we talk about responsible development for offshore wind? Well, again, I'll look primarily through the lens of birds, but the same concerns apply to other groups of species like marine mammals, sea turtles, bats. Actually, they're bats that utilize the offshore waters and migrate along the shore, and not a lot is really known about the extent and the patterns of that. We need more information. So it's important that we expand the research in this area, continuing the monitoring both pre and post construction, and that as we learn more, that we adapt and provide mitigation for unavoidable impacts. Next slide. So you start by evaluating what do we know about where birds are, and what habitats they're using, what species, how do they use them? Is that use at risk of being in conflict with the wind turbines? Can we minimize or avoid the risk? And the first step of that is a planning exercise that's already taken place. Carving out from that big rectangle that other funny shaped series of lease areas. That was an important first step. But it's not sufficient really, because we really don't still have enough information about how birds and bats are using this airspace and the ocean itself. And we do need to continue to still gather more information. There are two main concerns here. There's displacement. So, a number of birds rely on these ocean waters for feeding or even just for loafing areas during certain seasons. And we need to better understand what species are using the area when and at what density, and how the presence of the turbines might change that. And then the other concern is collision, and are birds and bats going to, crash into these turbines and suffer a fatal result? And so there are models that have been developed to estimate, based on what we know about how different species of birds fly at different heights, what altitude do they typically operate at, is that within the rotor swept area, how do they behave when they come near a turbine, how do they interact with it, but keeping in mind that this isn't just a daytime thing. So a lot of our migratory songbirds, like warblers and thrushes and things, and also the bats, they're migrating at night. And we know from radar that shows clouds of birds migrating, across the continent along the flyways. We know there's tremendous numbers of birds, but we don't know a whole lot about offshore because there isn't the equipment to gather the detailed radar or other data that we really need to understand this in more detail. Next slide. So some of the tools that we have now and tools that we need for the future to understand this, there are large scale models that are being applied using available data on what's known about bird distribution. Some of that data is quite incomplete or out of date, but it was sort of the best that Bohm and others were able to gather for some of the early planning. There are high definition flights that are done where planes fly transects back and forth over the lease areas, taking high definition photos. Those can be analyzed using computers and artificial intelligence and with the assistance of human beings helping to analyze the data. That can give us a lot of good information. There's also some project scale aerial flights that have been done with human observers. Radio telemetry is really an expanding area of technology that has tremendous potential. All these birds that I've been showing you here, and you can see it on this roseate tern, it's got a little tag on its back and then an antenna sticking out behind, below its tail. This technology is really getting very advanced and it's getting more and more miniaturized so that tags can now be put on something as small as a warbler. And then there are towers, Modus towers, that are set up in various locations that are monitoring these birds for all sorts of reasons, not just for offshore wind. Then the last three on this list are things that are rather on the edge of it that we really need more development. The radar to get more data on 24/7 and flight heights and that kind of thing. Acoustic monitoring could tell us more about the species of both birds and bats because they vocalize as they're flying. And then we need to develop collision monitoring for after the turbines are built to monitor, is the modeling that was done estimating what the collision risk actually, what the collision risk is estimated to be, does that bear out and is it actually close to what the reality is? Next slide. So again, here's a piping plover with one of those telemetry tags on it. And these could also give us not just locations, but also heights. What's needed here to build this technology out is we need a tower out there in the middle of the lease areas off the shore of Massachusetts. Next slide. Here's an example of tracking of roseate terns from Great Gull Island off of New York, Long Island, and over a period of 3 years. And you can see where the tracks go, but we can't track them offshore, so we don't know whether some of them were further down over the lease areas. Other species like piping plovers may have different kinds of distributions. If we could get a tower out there, it could be used for other types of monitoring as well, all sorts of other types of environmental monitoring. Next. Then I just wanted to show this about displacement. This is from Germany, where they studied using satellite tags, studied red-throated loons, and found that these birds just don't fly near tall structures at all. And so they were strongly displaced about 5 kilometers away from turbines and up to 15 kilometers to some degree. So what does that mean for a single project? What does it mean cumulatively? What does it mean in our environment for our birds, et cetera? There's a lot of questions to be answered. Next slide. And the collisions is where we really have the biggest gap in the technology, because we don't really have any method right now to monitor either acoustically or based on impact vibration analysis or that kind of thing to know if birds do run into these towers once they're built, and we're going to need that technology. Next slide. So just to conclude, this is a big tent. We're all in it together. I'm really excited because we have the industry folks, the clean energy folks, the workforce development, equity and environmental justice folks, environmental, everybody working together, working with the state and the federal agencies. There are various coalitions that have formed. Mass Audubon is part of the New England for Offshore Wind Coalition, organized by Environmental League of Massachusetts and in close partnership with the National Wildlife Federation. We also work with other state and national conservation groups on these issues. New York has really, not only has New York been out ahead in buying the wind, but they've also been out ahead in studying the impacts. So they have this environmental technical working group, or ETWIG. They've run state of the science conferences. They have tons of information up on their websites. They've formed working groups for the different groups of categories of things that may be impacted, like a group for birds. And they've even put in their own procurements requirements for the industry to fund research and monitoring and mitigation. So we'd like to see that in the Massachusetts procurement. There's a draft out right now, then a comment period open. So we're all in this together, and let's move forward in a responsible but rapid manner and get this industry off the ground. Thank you.
That was great, Heidi. Thank you so much. What a ton of information. Wow. So a couple of thoughts struck me while I heard you presenting, right? So I want to reflect on, actually, it's probably the same slide. This is the Block Island slide. So those 6 towers represent the totality of our US installation in 2021. And Nate, I'm probably going to be a little bit off on this number, but I think there are currently 8,000 turbines in the North Sea, 8,000 against our 6. Now, we like our 6, but we have quite a ways to go. So scale is one thing. Secondly, the importance of environmental advocacy in this development process. And an example of that, it didn't so much pertain to the birds, but I was glad to see you had the migrating whales in there, because your colleagues over at New England Aquarium have invested quite a bit in research on their migratory pattern. And as a consequence, something that is a burden of a bit, and that a cost factor that Nate and his crew has to integrate, and Ed and his team have to integrate in, is that there is literally a speed zone restriction in the Atlantic that regulate during whale migration periods, where the transport vessels have to slow down on their pathway through the zone. So there's so much benefit to advocacy. And I want to, again, thank Heidi and her team for doing that. 2 final thoughts. How cool is it when science informs policy? Wow, what a different paradigm. So keep up that work. And then my last thought is supply chain, right? Because we're talking about jobs tonight, in addition to birds and bats and whales and turtles, talking about jobs, and supply chain is what I said earlier, is where the bonanza is, where the jobs are. So when Heidi was going through her list, I stopped counting because I couldn't add any more numbers in. But how many sensor development and IT technology development opportunities are there associated with just the points that Heidi made to survey and assess these migratory patterns. So cool, very, very, very thoughtful and contentful presentation, and a perfect segue to Kevin Stokesbury, a distinguished professor of fisheries at Umass Dartmouth. I've known Kevin for quite a while. I know him to be a visionary. I'll embarrass him maybe in this introduction, but he is really one of the foremost scientists in the world on scallop research. He's innovative. He doesn't take no for an answer. So when he wanted to survey stock assessment of the scallop population, he went beyond conventional technology at the time. He invented a way to use the photographic video evidence of the population. And then Kevin, you know, it's hard to dispute when you got the picture of the ocean floor in a 6x6 square, and you can literally count and identify the species in that picture. It really brings to reality to the lay people what stock assessment means, because it's like not some I guess this many. It's like, look, this 66 in this frame, and Kevin's research has literally mapped the ocean floor from something like the Hague line in our border with Canada all the way down to Virginia. So kudos to him and his team. If you didn't hear the news recently, I couldn't be happier to tell you that BOEM, in its partnership with the National Academy of Sciences, has just asked Kevin to join their Committee on the Assessment and Advancement of Science. I know Kevin to be a brilliant scholar, but more importantly, I know him to be a truly decent human being. Kevin, tell us what you know about your new research areas.
Well, thank you very much.
Huh? Take that.
Yeah, I'm trying to stop blushing here. Thank you very much, and thanks everyone for joining us and listening. I'm going to work we're doing with Vineyard Wind, and but just as a segue in, kind of Heidi gave a much more in-depth view of this, but to kind of repeat what she was saying, you know, climate change is with us. Ocean acidification and climate change are impacting our science and our communities in the ocean environment, and it's something that we have to grapple with. Next slide. And in our particular area of the Gulf of Maine, North Atlantic area, the ocean is really increasing faster than other areas as far as temperature, and that's going to have quite an effect on all our species, particularly those and what you're looking at there in the chart is the fishery species that will be affected, and whether they're going to be extremely affected or partially affected based on a paper by John Hare and his colleagues at the Marine Fisheries Service. So, but definitely showing that there's an impact on many of our fishery species. Next slide. So, and wind farm is, wind and alternative energy. I looked at ways to try and start to grapple with this. But it's important to understand the types of structures and how they're going to be built. So this is a slide over from one of the English wind farms in Equinor, and you can see the density there as compared to the little ship down on the side. Next one. It's also, as Paul has mentioned, really an exploding industry along our coast. I think the projection I heard was 82 billion in the next 10 years, up and down our entire seaboard, and many different companies and different communities getting involved with it. Next one, please. So the thing is that this is, the ocean is not empty. And the fishing industry has used our continental shelf. We have an amazing continental shelf, and it's a very productive for fisheries. And it's a busy place. There's a lot of ocean planning, but if you look at the map of where the wind farms are projected to be developed, and for example, the scallop management, which is on the map adjacent to it, there's a fair bit of overlap. And so I'm going to spend a few slides talking about it. Next slides. This highlights it more. And if you're interested in this type of data, you can go to the Northeast Ocean portal and you can get this. What you're looking at here is the vessel monitoring system, which each of these fisheries has. So it tracks where the vessels are, and it's an interpolation of where they're fishing and where they're transporting. And this is overlaid on grids where wind farms will be developing. And so for these different fisheries, such as squid, scallop, surf clam, there are areas where there's definitely some overlap. And so the trick is going to be to figure out how these two industries can work together, because they're both harvesting sustainable energy, one in the form of power, the other in the form of food. Next slide. And it's a very important economic engine, which I think has also been mentioned tonight. New Bedford's the #1 fishing port, has been for the last 20 years. That's largely driven by the scallop landings. The scallop industry is worth, it lands about $500 million a year, which is on par with what the lobster industry lands. So those two industries alone are worth $1 billion annually for the Northeast. Next slide. And if you look at the scallop management, or just as an example, the ocean is parceled up. There's areas that are closed permanently for habitat. There are areas that are open on a rotational management for the scallop fishery, and also open and closed seasonally for bycatch. And then some of the other things that people have been talking about, like right whales, are also something that you have to consider. Next slide. So it's a busy ocean, and then you have other types of fishing gear as well. Now I took this up on the northern edge of Georges Bank. This is a shot of a radar. It's on a 6 nautical mile radius, and each one of those dots is a buoy, which is a target. It's a line of lobster traps, and then there are a couple of vessels in there as well. So already, when you're out at night or in a storm, there's a fair bit of obstacles that you have to be aware of. Now, if you go to the next slide, that same screen, when you overlay a turbine grid, which is what the Coast Guards have just talked about, running north, south, east, west on a 1 nautical mile grid, you're going to have about 169 turbines in that area, or 129, or 121, pardon me. So that is a lot to be aware of and a lot to be looked at. 1 nautical mile may seem like a lot, but you, when you're traveling 3 or 4 knots, it's something that you have to be aware of constantly. And so this is just the kind of thing that these two industries are going to have to grapple with. Next slide. So in doing that, Vineyard Wind, which is really fairly far ahead in its development, they came up with, or they approached us to work with them to do a monitoring plan to figure out what the concerns of the fishing industry are, what we could do as far as best practices. They asked us to hold a series of meetings with the different fishing communities along the coast to talk to them about the data that was available, and then to discuss with the fishermen what their biggest concerns were, and also to meet with the regulators and to talk about their concerns. And Steve Cadron in our department led this effort, and I and my colleagues were a part of it. So in doing that and in having these meetings, if we could go to the next slide, we for the fisheries, we came up with 4 different types of surveys: the benthic, trawl, a trap, and a plankton, and I'll describe each one of those briefly, and then also suggested a number of supplemental studies. So we moved ahead, and these are all set up in a before-after control impact design. So you want to get out there and find a control area, and then the impact area, make sure that you understand how the what the number of species are, how they're changing seasonally, how they're changing in nature. And then when the wind farms are constructed, you can see what change might have been caused from the wind farms compared to just naturally. So the next slide, please. So the first of these is a trawl survey. And this is a otter trawl, similar to what the Marine Fisheries Service does. In fact, all the three surveys I'm going to tell you about, one of the principles that everyone wanted us to follow was to tie them into other large-scale surveys, so that it wouldn't just be a single point study of vineyard wind. We'd also be able to link into larger databases. So this survey looks at the multiple groundfish. They go out seasonally. In fact, they're sailing tonight. Chris Roulihan and his team are going out, sail from New Bedford just now, and they sort and identify the different groundfish species. Next slide. Some of the work that my team are doing is a Ventless trap survey, along with a plankton survey. So we go out to randomly selected locations inside the vineyard wind area and in an area next to it, which we're using as a control, which will not be developed. And we are looking at the Ventless trap survey, which is basically lobster pots, some that are commercial and some that have the vents closed, so we can see the small size lobsters. This is the same survey that both Rhode Island, Massachusetts, and Maine do, so it's tied into their surveys as well. And we also at each station sample the ichthyofauna, so we look at larval lobster and also the larval fish, and we put a black sea bass pot in. So it's starting to build a baseline study which we can use to compare the changes. Next slide. And then the third study is the drop camera study that Paul was mentioning that we do with the scallop industry. So it's the same technique, but we do this on a high resolution grid inside the impact and control area to get a real baseline of what's on the seafloor. And this is the macro invertebrates, scallops, sand dollars, some of the ground fish that stay close to the bottom as well. Next slide. And that survey is tied in. If you look at what we did in last summer, that survey is tied into our larger scallop assessment survey, where we're looking at the conditions up and down the continental shelf. So this is a huge database that goes back 20 years and really provides us with a window of what is the macroinvertebrate community of the continental shelf. Okay, next slide. Then to expand it out, so those are the particular focus with the vineyard wind that we're working on. And then as well, some of our other colleagues at SMAS, we have this amazing oceanographic model called the FECOM, which Dr. Chen and his team have developed for years. And this was developed to look at, with SMAS, we were using it to look at the distribution of larvae, both fish and scallops. It's been used for all kinds of things. It actually encompasses the world. It was used to look at the fallout from the nuclear spill with the Japanese earthquake. They used it to tell Hui where to look for the black box for the Air France bus crash off of Brazil. It's an amazing model. In this sense, it's been work with BOEM, where they are looking at what will happen when you place turbines into the water, how will it affect the current and the water column, and also what will the effect be of pulling the energy from the wind, and how might that affect or not affect larval distribution, in this case, scallop larval distribution. Next slide. Some of Steve Cadron's work. There's also telemetry studies. This is more with Boehm, and also around the Cox's Ledge area where Orsted is looking to develop. But they're looking at this cod spawning stock group there and trying to identify both the abundance of the animal and also the homing ability of it using gliders, doing glider tracks and acoustic arrays. Next slide. And then we have our school is an interdisciplinary school. So it was, social science is an important part of it. And stewardship, Gavin Fay's lab is looking at balancing the human activities and the environmental stewardship. They just published a recent paper on this and comparing the two industries and how they might affect different components of the coast and the coastal communities. So the next slide. So this is an idea I've been trying to. The wind farms and the fisheries are both massive. Fisheries have been studied for a long time. The wind farms are new to us. We need to have a scientific framework that allows us to try and take into account the ecological, economic, social, and institutional effects, and on different scales. And so right now, there's a whole series of groups from the ICES Offshore Wind Working Group, which works with both Europe and the States and Canada. There's the ROSA, which is a regional organization putting together scientists and industry members to try and figure out how we can look at the impacts of these industries on different scales, and how they can try and work together to figure out how to both provide sustainable energy. Next slide. And with that, this is one of the species that I do think we need to work a little more on is the squid. Squid mop that we saw on our last drop survey, and one of the squid working by it. So there's still, although we've made a good start, there's still a great deal of work to do. And with that, I'll sign off. Thank you, Paul.
That's great, Kevin. And it really underscores sort of two takeaways for me. One, the need for continuous environmental monitoring of the ocean environment as this industry emerges. Something which I'm so pleased to see that the industry leaders, the ocean wind developers themselves, are prepared to invest in and support the research in those areas. So kudos to Nate and his crew and his competitors, who also recognize that they need to share the ocean. And the best way to do that is to have good science to make your argument rather than these emotional things. And then lastly, every time I hear Kevin speak, I come away convinced that he and the SMAS team know more about the North Atlantic than anybody in the world. They've been following it since the Magnuson Act required vessels to start monitoring and cataloging catch by species, by place, by time, by date. And the modeling that Dr. Chen and Kevin and Steve Cadron have done is it's just first-rate stuff. So Kevin, congratulations to you for leading that.
Thank you.
It segues to our main event. Nate, patient Nate. I'm glad everyone's on mute because I won't compel them to sing happy birthday to you, because I understand it may be your birthday today. So I don't want to go crazy on you, but Vineyard Wind secured the first procurement from Massachusetts. They've subsequently gone on to secure other procurements from Connecticut. They recently, to certainly my delight, and I hope others, petitioned BOEM to reactivate their construction and operating plan. They had switched the size of their turbines, and in the previous environmental review process, it had been a little bit touch and go, but it appears we've turned the corner, and hopefully, this project kicks off this year. So Nate, tell us what you can about the exciting developments there at Vineyard Wind.
Great. Well, thanks, Paul. I perhaps conned into this on my birthday by the incorrect date on the slide there. I do want to say, though, that, maybe I'm a nerd, but looking at this panel and seeing the wealth of real sort of players and movers in this process that started long before I was ever involved in offshore wind is really impressive. I mean, Ed and yourself and what's been going on there with the port and with the interest in New Bedford, Heidi, Mass Audubon, Umass Dartmouth, of course, as the organizer, and also the wealth of knowledge that they've brought to this issue. Pat Haddad is the policymaker for offshore wind in Massachusetts, and I think that extends through the country, because the work that was done there was incredible. I know we're short on time, so I'm going to try and cruise through this stuff. Talk a bit about who we are and our approach to development. We talked about responsible development. It's multifaceted and more than I can cover in a few minutes. Our projects and the latest developments, as Paul has highlighted, we'll mention those. Some of the work we're doing in workforce development, the challenges of sort of building this industry from the ground up in short order. Ed and Paul and others have touched on that. The engagement effort broadly, both in communities and also with stakeholders, fisheries, environmental interests as well. I don't know how much time we'll have for questions, but so Vineyard Wind was established now about 10, 11 years ago, New Bedford-based company, offices in Boston, partnership of two major renewables and offshore wind companies in CIP and Avangrid Renewables. We have two federal lease areas in the Massachusetts, Rhode Island wind lease area. You've seen a number of maps. Paul showed a bunch. Vineyard Wind 1 is the project that's at the fore right now. We're at the goal line and feeling really good with the developments of the last week, especially, but it's been a long slog. Park City Wind is in its infancy, and we're just beginning the permitting process there, and we're excited for that one as well. So you can go to the next slide. When we talk about responsible development, why don't you slide, Jamie, all the way to just fill all these in here. There we go, that's good. We can barrage people with it. Local communities have driven this issue, and it's areas like New Bedford who see the opportunity and also the concerns with conflicts and sharing the ocean, but also the communities that we're working near. The islands we're a key player in the Cape Wind discussion, town of Barnstable and the Cape as well. We're proud to have achieved agreements and long-term relationships with these communities that's supported not only our efforts, but really socialize the idea of offshore wind as it interacts with communities. The environmental agreements and environmental research, kind of melds together, and it's all there. We're very proud of having achieved a landmark agreement with a number of prominent NGOs at the national level to address this critical question of how do we work in these areas with climate change being what the key existential threat to so many species, and also working in the context of critically endangered species like the right whale. It's the same as it goes for fisheries and avian species. We need to be doing these projects with the utmost care because it's those environmental resources we're seeking to protect. A lot of that conversation has also evolved, not just the work that Kevin has discussed there and other broad-ranging fisheries research, but trying to move some of these innovations forward. Heidi had discussed some of the right whale tracking and monitoring challenges, and those with avian as well. Offshore wind presents a special opportunity where we are not only furthering the research for our parochial interest, but also in the broader sense. And some of the research that's been done on right whales in the OCS area has really brought some more broad-based science. And as Heidi's mentioned, climate change is creating an even more challenging and dynamic environment for monitoring and management because the behaviors are changing. We see that obviously with lobster and with other things, but the right whales are moving in different patterns, it's understood, due to warming oceans. So the support in fishery science and all that is broad. Kevin's actually captured so much of it so well, but there's actually so much more that's been going on. The two projects, Vineyard Wind 1 and Park City Wind, share a lot of the fundamentals. I know a lot of folks on here can find some of the data, so we might gloss over this, but we're about 30 miles south of the Cape, 15 miles south of the islands. Vineyard Wind 1 is an 800 megawatt project. We're talking about power for 400,000 homes. That was awarded in the first Massachusetts solicitation precipitated by the legislation that Representative Haddad was instrumental in passing. So we began our permitting in 2017. We've all probably on this call been following some of the ups and downs of the permitting process as it relates to Vineyard Wind and also really offshore wind more broadly. Figuring out how to navigate this really complex matrix of federal, state, and local permitting, as well as engaging all the stakeholders who have been involved since the siting began in these areas 10 years ago. So I just wanted to highlight, this is a perfect point here. This complex matrix does culminate, and some of the graphics have shifted, although I don't know how helpful the acronyms would be. The final EIS is sort of in process at the moment. The Bureau of Ocean Energy Management indicated they're going to restart and resume the permitting, and we hope for a final set of review and authorizations there this year, and to begin construction this fall. So it's a really exciting thing, especially after years of delays, especially after the sort of fraught history that Cape Wind brought upon this, with sort of struggling for decades on this. We seem to be really at the precipice here. If you were to see this on Park City Wind's process and many of the other developments, you'd see a lot of these boxes being white and unfilled. But this process is becoming, is what we move through. It gets all the way down to the local level, and we're just about to complete it and share that perspective. Next slide. So Park City Wind has a lot of the similar fundamentals. Serving the state of Connecticut, we're talking about 14% of Connecticut's electrical supply. Again, the fundamentals are very similar. We're talking about the jobs, direct employment in the thousands, and when we talk about the downstream impacts of that, we are talking about for each project employment implications in the 10,000 range, which is very exciting. We can skip this one. This project is anticipated to begin operation, or excuse me, begin construction in 23, just around the time 2023 when Vineyard Wind is anticipated to bring our first project online. The GE announcement just a few weeks ago, it was a really exciting one, the 13 megawatt project. We can go to the next slide here. Sorry, I'm getting ahead of myself here. This one-by-one turbine layout agreement occurred between developers. We're talking now towards the end of 2019. And it was really the culmination, as we started with this siting discussion that Paul discussed, with a large rectangle of ocean, and how do we cull that down to the areas that are less sensitive to fisheries, less sensitive to migratory pathways, marine species navigation. Finally, sort of locking in an agreement on this one-by-one grid, really presents the sort of one of the last great refinements that we have seen here. And while it reduces the overall capacity, it provides a level of predictability for marine users and also for developers that we can move forward with. And again, the Coast Guard, played a strong hand in endorsing this structure, and so we see it as a really positive movement, apart, separated from the sort of idea of developing an individual level on layout. Next slide. We can skip through this. It's fundamentals of the offshore wind farm. And Paul had touched on this, and here's where we are, Paul, with an evolution from 1990 of half megawatt turbines to 30 years later, looking at what we're going to be using, which is a 13 megawatt turbine, and obviously already discussions of even larger capacity turbines. Now they come with technical constraints and their own sets of issues as you get larger, but what we do see is fewer aggregate impacts. It's efficiencies that are gained in these machines, and also fewer locations of turbines, so more efficient use of our oceans. Next. So yeah, wanted to highlight here that the GE turbine is going to basically it ultimately amounts to 62 turbine locations in the ocean for Vineyard Wind 1 to power 400,000 homes. So what that means is for each location, it's greater greenhouse gas reductions, more energy, of course, more reliability and affordability. It's been lost on a lot of folks. We've kind of gone past it, but these projects are becoming affordable and cost competitive to the point where they're actually resulting in ratepayer savings rather than the ratepayer cost premiums we were talking about with earlier projects. That's really, maybe for people not in this conversation, but for laypersons outside is critical. This perception of sort of taking a bath on renewables as part of your energy bill is really is going to the wayside, and that's important for everyone for this to move forward. Next slide. Workforce development. We don't have a lot of time to go through all these, but you know, a lot of investments are made around Vineyard Wind 1. We're excited, you know, with this project, it's been focused around New Bedford, the South Coast, trades and innovators in Massachusetts. We've been fortunate to partner with and you know, take on or tap into the resources of our community colleges, worked with BCC, obviously Umass, Dartmouth, and some of the other workforce training and jobs related organizations, as well as trying to cultivate a supply chain network that we really have had to devote a lot of time to. And we're really, you know, sort of playing catch up. We've got a 25-plus-year-old industry in Europe, and we're approaching the same industry that's going to be in much shorter order. So this is a task, but I think you've heard from Ed, and there's a lot of work being done. I think we're potentially, you know, just about ready to tackle it, and we will be starting it off in October. So it's going to be exciting. Next slide. Yeah, just a brief bit about engagement. I mean, this has been the core of how these projects are developed, and it's with folks that are on this call. It's with the folks that they speak with. It's also with the neighborhoods. It's with you know, individuals who have concerns about the environment or concerns about development. So we've been doing this extensively, shifted obviously to digital resources, and that's been a strain, but one way I think we've patched up well. We look forward to meeting with all the folks on here in person in the coming months when that's safe to do so. But you know, the core of this, the science, the making connections, the outreach, as well as the engineering and logistics that we're going to be doing in New Bedford and other places is critical to getting this industry off the ground, and we're excited for it. That's it.
That was fabulous. So
had myself at 10 minutes. I hope that was okay.
No, you blitzed through it, but you hit all the high points and a few takeaways that I had. So it just blows my mind that every one of your projects takes 1.6 million metric tons of carbon out of the atmosphere. That's huge. That's big time stuff.
Every year.
Every year. So, and provides electricity to consumers at a price point that's less than the retail nut people are paying now. So how about that? 14% of Connecticut's electricity in the first project, 14%, right? So I'm not a math wizard, but I think like 5 or 6 times that, and you get the whole state done, right? So it's just cool. I love the notion of, and it's so true. We are still in Massachusetts. We are still dealing with what I call Cape Wind hangover. You know, all of the baggage that project, for its pioneering efforts, brought to the Commonwealth has really been a burden for us to overcome. So, you know, thank God Pat and others see through that. The beauty of offshore wind is that it's constant, right? It isn't one of these things where like the sun goes down and the wind stops. So it's a all day, all night, 24/7, 365 deal. And we around here just are beneficiaries of an earth thing. I like to call it an earth thing. I'm not a scientist. I call it an earth thing. What I mean by that is people don't realize that when they look at the weather map, like we have in the last few days, we're watching the snowstorm. Like, what's it going to do? Is it going to take a Nantucket and veer off? Well, why does it do that, right? It does that because it's the interaction of the Gulf Stream and the Northern Jet Stream that happens every day, every night, right off our coast. I'm sitting here in Horseneck. It's like 15, 20 miles south of where I am. Every day, every night, that goes down. And that's what this play is in the offshore wind energy industry. So thank you for everyone for the content. Jamie, how are we doing on time? Do we have questions? Do we have an opportunity to respond to a couple at least?
We certainly do. I'd like to invite people at this point. If you do have questions, if you'd like to, you know, again, go down to that the reactions spot and raise your hand. If you're on a phone, if you want to hit *9, that will raise you up here and we can see where you are. While people are sort of fumbling through that, I've got a couple of questions that came in through the chat session. And I'll sort of just throw this to the group and let you sort of bandy it about. What lessons have been learned from large-scale onshore facilities such as East Texas in terms of the economy of scale and wind projects that have gone on down there?
Nate, you want to take a whack at that, or you want me to try to like respond?
Well, from onshore, I mean, there's so many. There's obviously a wealth of the sort of technical advancement, the onshore versus offshore. But you know, we are dealing with, and we recognize that even though we have these models from Europe, and we have a wealth of information about the interaction with the natural environment and optimization there. We are working with our own grid, with our own resources, and in the local environment with our own set of, you know, ecological dynamics. But one thing I would highlight, you know, there is a with visual impact being at the fore and brought so into stark contrast with Cape Wind. The ADLS, the automatic lighting systems that they've used on onshore wind facilities, have served to offer a model for folks who are concerned about viewshed impacts, which may be less concerning to folks like us, but are concerning to certain community groups. To virtually eliminate, you know, the nighttime lighting viewshed impacts that occur. There are countless others, and there's a lot of research that conforms somewhat, but not entirely, in terms of avian species. But I mean, how you might echo that, you know, the onshore and offshore, it's an entirely different set of environments with entirely different set of challenges.
Yeah.
I don't know if there's anything anyone else would add.
Yeah, I would just add, I mean, it's hard, it's sometimes easy for us to forget up here in the Northeast just how massive onshore wind is in the U.S. I mean, I think we're the world's leader in onshore wind.
Yeah.
And there's a supply chain
Yeah,
that
exactly.
with onshore wind that's mostly in the Midwest and in the Gulf of Mexico. So I think there is a lot that we can, as a country, kind of bring to bear from a supply chain perspective. And I mean, Laura Douglas, right, Paul? She came from Iowa, where wind turbine technician was a big part of her community college, you know, the one that she ran out there. So there is a lot of know-how that exists, and you know, bringing that knowledge to bear, the onshore knowledge to bear, whether it's the supply chain or the training, is going to be really critical as offshore, you know, takes off. Now, as Nate said, it's not going to be the same thing, and the scale of the actual turbines is quite a bit smaller. But I think, you know, we're going to have to look at every opportunity to find synergies and ways to make it work in this U.S. opportunity.
All right, let me switch over. Maria Bartlett has a question for us.
Well, let
Maria?
me just add one more thing too, Jamie, on that point about the Texas example. So first of all, people would be surprised that Texas is the #1 onshore wind energy producer in the United States, right? People think of Texas as an oil state, but it's really now become the #1 state in terms of the production of offshore wind, which is, I think, a metaphor for the offshore wind development companies, who by and large now are the oil companies, right? Shell, the renewable energy companies in Europe that have invested in the US are giant. And then the last lesson learned is what they would call their Scada systems. I mean, how they monitor the performance of their devices, how they provide online, real-time system diagnostics to this system. I was sitting in the control room in Portugal one night, and I was watching a wind field in Texas. And they knew every single device, what it was doing. So if you got 11 things in a row, and like number 8 is the only thing out of line, you know that's where you need to send your maintenance team, because something's goofy with number 9 or number 8. So this idea of remote monitoring and SCADA analysis is something that the offshore wind industry has adopted from onshore wind, because it's such an effective and important part of their management. Jamie, sorry. We're close to end, right?
Great information, and I appreciate the illumination of that. Maria, go ahead.
Yes, hi. I'm just curious. I only heard it mentioned once, what the involvement of the Coast Guard has been in all of these planning. And I'm thinking in terms of security of the platforms when they're developed, you know, against any kind of sabotage or.
Nate, you want to take a whack at that one?
Well, the Coast Guard's been deeply involved in the, with their insights and consultation around safety for marine users, and that's a very complex and complicated thing. The big challenge is, if there's an emergency, with a boat that is in distress within a wind farm, how does a Coast Guard helicopter efficiently get out there? And adding to that, how can these facilities potentially offer some supports there directly? So that's about communication and coordination. And of course, in terms of layout and those types of things, there's been a lot of input there. When it comes to sabotage, it's all critical, classified as critical energy infrastructure. So it achieves this higher level of protection and scrutiny and actually in some instances confidentiality. But I think one of the things you want to consider is that with our energy assets that we have, spread out across the country in many forms, everything from community solar to rooftop to onshore, offshore wind, nuclear plants, and coal plants and the like. While there is obviously the potential for some type of sabotage, it seems like it'd be low on the register for groups that would want to do harm when you've got a couple of pilings placed out in the deep ocean a mile apart. Although it is there's extensive levels of monitoring and technology that each turbine is equipped with, and they're monitored constantly. So there is some response capability there as well.
Yeah, and I think they're no more or less vulnerable to cyber attack or terrorist attack than any of our conventional assets now. So
that's a big new horizon. I think that folks are focusing on, and you made a great point, Paul, that actually the real risk to our energy infrastructure in general is not necessarily physical, but rather technological. So it's a good point.
Yeah.
Heidi, did you have something you'd like to add?
I had one other thought on another point that I just wanted to add before we conclude. And that is just to mention the importance of the transmission planning and the regionalization of the markets and the transmission. And I'm by no means an expert on this, but I've been reading some of the reports that are out there and showing that, we have these great interconnection opportunities, like at Brayton Point, for example, and some other places. But once those first easy plugs are filled up, then what's going to happen? And if we don't plan and develop a shared offshore grid for all of these projects to work together, then there's going to be massive upgrades of the land-based grid needed. And it's going to create tremendous both environmental impacts on our forests and farmlands and wetlands, but also conflict with the public, as well as increased cost in the long run. So I think that we really need to be paying close attention to that aspect of all of this as well.
That's a great point. And there is starting to emerge this conversation about, is it a federal infrastructure investment opportunity to build an offshore grid spine from Cape Cod to Cape Hatteras? Now, Kevin will have to figure out whether the, what the impacts are on the ocean environment, but this notion of having a central grid spine that is an undersea spine that the offshore wind farms tap into is something that people are starting to talk about. I think we have one more question from Almy R.
Just one quick addition to that,
Jamie?
Heidi, great point for bringing up. I would want to highlight
ahead,
the onshore issues are paramount as well. The first handful of projects do have a pretty clear pathway, but we see pinch points onshore that need to be addressed, and it lends itself to critical planning over the next decade.
Right. Before we get
and
to
the ancillary conversation too involved. I was going to say the ancillary conversation. The third leg in that stool is storage, right? I mean, how can we develop a storage capacity so that electrons that come in onshore that exceed our demand capacity get stored sufficiently in some battery capacity? Jamie?
Excellent point. Let me get to one other chat question, and then we'll come to Alme for the raised hand. Just this question sort of port and this fishing versus wind turbine kind of dichotomy. Do we see these as really being, how is wind going to potentially negatively affect the New Bedford economy? And is that going to be seen in like in the port itself? Are we going to see competition for slip space and for other critical infrastructure? Again, it will be shifted to the wind industry as opposed to being there to support our fishing industry. Or is this more of an additional thing that we've got the capacity with those technicians and there's plenty of room for our existing supports to support both of those? Ed, that might be a better question for you.
I guess I'll take the port infrastructure question from my former employer. I mean, over the last decade, we've really worked hard to develop new infrastructure. Thanks to the to the delegation and the state legislature, we have funding for dredging, which is opening up different parts of our waterfront that hadn't had any activity. And to be clear, almost all of that is going to be commercial fishing related. So dock space that's opening up, and so the dredging project is a massive project that is we started about a year and a half ago, and we're in the middle of the New Bedford Port Authority is in the middle of it now, and that's going to open up a lot more infrastructure for everybody. And because of that, New Bedford is also growing as a commercial fishing port at the same time. So, having more space for commercial fishing and for other potential uses is going to be really important. New Bedford is the #1 fishing port, but it's not the only thing we do. There's a lot of marine contracting, a lot of the ferries that run out of there, the shipyards, pleasure boating, international clementines and international cargo and things like that. So New Bedford is more than just fishing now, and those different uses all coexist and complement each other, I would add, in a way that creates a really dynamic port economy. So I think we've been developing the infrastructure certainly over the last decade to be able to accommodate more fishing vessels and more new opportunities. So I don't think that will be a big issue for the port.
Excellent, thanks. Al, let's switch.
Kevin, you want to respond to that at all?
Well, yeah, for the offshore component, I mean, there's definitely going to be, I think, some, there's going to be some fishing industries that are going to lose and some that are going to benefit, both recreational and commercial. Some of the types of fishing that are done now, and a lot of them aren't. It's not so much that they're off the Massachusetts. The way the Massachusetts area was defined, and the reason it was kind of cut in half, which is what Paul was referring to with the dog, was because the New Bedford had a fishing advisory panel, which I was on, and we all presented a bunch of data and looked at the overlap of different fishing industries and actively decided to try and cut it and accommodate the fishing grounds as much as possible. That's not the case in some of the wind farms further south off New York and such. New York doesn't have a lot of scallop fishing activity. It has some, but it doesn't have a lot. But the areas in the Mid-Atlantic, if they're all developed, what's proposed, it'll overlap about 40% of the scallop fishing ground. So that would have a major impact if you're not allowed to fish in there. That's still debatable. What Nate was talking about with the increased size of the turbines, if that means there's less turbines in the area and they're spread further, then perhaps it'll be possible to fish, perhaps it won't. But it's got to do with the Coast Guard regulations, with the way the wind farms are operated, and also with the insurance companies for the fishing vessels. So there's a lot of discussion and consideration to take into account with it. Some industries, like perhaps the lobster industry, it might benefit because you're increasing the habitat. You're also these installations are going to act as islands. You're introducing intertidal and subtidal zones into areas that are 20 or 10 miles offshore. So it's going to be, it's interesting time. It's certainly one though that you need to try and do as much work on as you can to try and figure out how to mitigate the impacts and make it as positive for everyone as you can.
And then a few closing thoughts on that point too. So there's some beginnings of scientific evidence that for recreational fishing activities, for example, rather than commercial stuff, that the towers and structures themselves almost become, as Kevin was suggesting, almost like artificial reefs, these little islands in the ocean. So it attracts the formation of sea creatures that are food for somebody else in that food chain. And then, the folks who are out there taking recreational fishing people on day trips have found it to be a very productive area. It has attracted fish to that area. So again, they're not the draggers and the commercial folks that Kevin's talking about, but sort of the day charter guys are kind of enjoying that quite a bit. And then another weird opportunity is the convergence of skill sets of people who are in the fishing industry and the marine industry and people who are in the offshore wind operation and maintenance side. So there's a lot of evidence in Europe where fish harvesters who have been limited in terms of the number of days they can work on catch, then split their shift with offshore wind, working on boats as deckhands and vessels. I remember when we did the study, transportation and maritime transportation and deckhands and workers like that, mates, was going to be one of the deficiency occupations in New England because we don't have those in sufficient number to satisfy what will be the demand. All right, last question with Almy.
Yes, please.
Hi, my name's Rob Almy. I'm the former manager of the Santa Barbara County Energy Division, and for a decade, I was involved in representing local interests as offshore oil and gas were developed in California. I was also a lecturer at UC Santa Barbara and specializing preparing environmental impact reports. I wanted just to make a couple of observations. Most of my questions have been answered, but if you'll bear with me. First of all, I think there's a huge difference between what's going on here and what was going on the West Coast in the 70s, 80s, and 90s. And nothing that humans do is perfect, but this is much better, a whole lot better. I want to observe that offshore, the manufacturing and supply side of the industry are likely to be less compatible with tourism than servicing and maintenance. And you may be able to not rely on the same ports. So New Bedford, I live next door to New Bedford. I live in Dartmouth. And my family's been in the area for a while. So I've seen New Bedford and New London, where I used to live, go through their cycles. And I think it's great. But I think some of the other coastal communities could support some of the services as these things get installed. My last point is this business about the structures acting as reefs. The Marine Sciences Institute at UC Santa Barbara has done a lot of work on the platforms off the coast of California. And now that some of the older platforms have reached the end of their service life, there's a lot of pressure to leave them in place to serve as reefs and help support marine organisms. I have an open question because I'm older and I've seen the oil and gas industry go through their cycle. What is the service life of these facilities? And presuming that they have to be replaced because you're not mining or depleting a resource, how can that be done in some kind of an organized manner if, say, the life of these facilities is 25, 30 or 40 years? And, how do you, that means that as you develop the offshore fields, you may get to a point where you get all done with the initial development and you turn around and you start replacing these things or rebuilding them. So that's kind of a long-term view. Anyway, thank you very much for putting this on. I agree that that the first project out here, Cape Wind, really stirred the hornet's nest, but certainly things are better. And Mr. Mayo, good luck. You guys are on the right side of things here.
Thank you.
Nate, you want to talk 2 seconds about decommissioning?
Sure. Yeah. We're learning from Europe. They're beginning to do that work, decommissioning, and also seeking, the technological structures that will, structural sort of planning that will allow for, repowering and gaining efficiencies in these things. We heard just more recently. I was astounded to find out that with these more recent turbines, they can increase in efficiency by not just by internal component changes, but actually even by software updates. In other words, the scale of innovation here is so incredible. It is a question. There's a useful life anticipated of 25 years typically, or 25 or 30 years. But that's on the horizon that I think the thinkers behind this stuff and this innovation wealth that is driving us to larger and better turbines is really focused on, because there is a decision that's going to need to be made in the 2030s and a little further out as to what the next thing looks like. So it's a great question, but I do think at this point we're married to a structure where we're going to be building these projects, and then we are sort of bound to fully pay for the decommissioning of them at the end of their life. And that's also the end of our lease. So that's a policy, discussion that will happen in the coming decades.
Yeah. Well, listen, I want to thank the speakers for all of the content. This was way more than I certainly even expected. David Cole, I know you're out there. I can't see you, but kudos to you and Jamie for pulling this together. And Jamie, I'll toss it back to you for closing thoughts.
Terrific, thank you. We had at least 6 other questions. They ranged from sort of the efficiency of transmission lines, looking at the other people on the coasts in terms of communities that might be affected from Quonset up through Bath Iron Works. So it was interesting to see sort of the range of things, big oil getting involved in this game and how that's going to affect future developers. So clearly there's lots of things that people are interested in and learning more about. So I encourage all of you to continue to read the papers, follow Vineyard Wind. They've been a really excellent organization in terms of providing public outreach and staying connected with the community in their process as they're doing this work. In final thoughts, we will be posting the recording of this on the university's website, so umassd.edu/campus sustainability. We'll have that located at that site if you're looking to share this with friends or family, or if you just really want to watch it one more time. To our presenters, thank you so much for your time and your expertise. I really appreciate all that you're doing in these spaces. I echo Paul's thoughts that science is such a critical way for us to make better decisions. And it's nice to see us returning to that, obviously led by good policy as well, because good science leads to that. So thank you to everybody for participating tonight, and we look forward to seeing you at another program in the future.
Thank you, guys.
Cool beans. Great job,
show.
baby. Thank you, man.
Thank
you all.
you for doing this.
Cheers.
Thank you.
Thanks.